In 1942, the U.S. lost access to natural rubber, threatening its war machine. The solution came from polymer chemistry, creating synthetic rubber in the lab. Chemists like Carl Speed Marvel led a massive effort, uniting universities, industry, and government. They developed government rubber styrene, GRS, a substitute that kept tanks rolling and planes flying. Early versions weren't perfect, but they worked. By war's end, the U.S. produced nearly 1 million tons of synthetic rubber annually. This crisis-driven breakthrough launched a new era in materials science. Synthetic rubber soon found its way into everyday life: tires, shoes, insulation, and more. The war proved that focused scientific effort could solve even the most urgent material shortages. Chemistry had delivered a miracle under pressure. Before the war, plastics were novelties. After, they were essential. Wartime shortages of steel and aluminum drove the search for new mass-producible materials. Scientists delivered. Plexiglass replaced glass in aircraft, making planes lighter and safer. Nylon, invented for stockings, became parachutes, ropes, and flak jackets. The military's needs transformed plastics from curiosities into vital resources. New vinyls and polyethylene insulated radar cables and waterproofed gear. After the war, this explosion of plastics research reshaped civilian life: Tupperware, records, furniture, and more. The quest for better military gear laid the foundation for our modern, plastic-filled world. Materials born in crisis became the building blocks of peacetime prosperity. The plastic age had begun. Radar gave the Allies a decisive edge, a technological advantage that would reshape the course of the war. It was a game-changer, providing critical information in ways never before imagined. Seeing through darkness and fog with invisible waves, radar pierced through the limitations of human senses. It unveiled the unseen, turning potential threats into visible targets. The MIT Radiation Lab was the epicenter, a hub of innovation where brilliant minds converged, where top physicists turned theory into battlefield technology, transforming abstract concepts into tangible tools of war. They raced against time, driven by the urgency of the global conflict. The key breakthrough, the cavity magnetron, generating powerful microwaves for compact, high-resolution radar. This device was a marvel of engineering. It allowed for smaller, more effective radar systems. Luis Alvarez and others developed systems like ground-controlled approach, guiding planes home in zero visibility, ensuring the safe return of pilots and aircraft in the most challenging conditions. Night fighter radars turned Allied aircraft into deadly hunters, transforming the night sky into a battleground where enemy planes had nowhere to hide. Radar was crucial in the Battle of Britain, the Atlantic, and the Pacific, protecting convoys and winning air battles. After the war, radar technology found new uses: air traffic control, weather forecasting, even the microwave oven. Radar taught us to see the unseen, making the world safer and more connected. The fusion of science and necessity had changed warfare and daily life forever. The invisible became visible, and the future was transformed. The legacy of radar endures in every corner of modern technology. In the shadows of World War II, the Manhattan Project emerged, an unprecedented alliance of brilliant minds, shrouded in secrecy and urgency. Scientists, engineers, and military leaders joined forces to unlock the power of the atom before Nazi Germany could, forever altering the course of history. It was a race against time, sparked by fears of a Nazi atomic bomb. Brilliant minds united to unlock nuclear fission. At the University of Chicago, Enrico Fermi's team achieved the first self-sustaining nuclear chain reaction. Secret cities like Oak Ridge and Los Alamos sprang up. Led by J. Robert Oppenheimer, the project culminated in the Trinity test. The atomic age had begun. The bomb's power changed war forever. It also opened doors to nuclear medicine, clean energy, and new scientific frontiers. The Manhattan Project showed science's dual nature: creation and destruction intertwined. Science had changed the fate of nations and the future of humanity. The end of World War II was just the beginning of a scientific revolution. Wartime investment in research fueled the jet age, the digital revolution, and the space race. The partnership between science and government became the engine of modern progress. The war proved that curiosity-driven research leads to breakthroughs no one can predict. Today's challenges, climate change, pandemics, demand the same spirit of innovation. The story of WWII science is a blueprint and an inspiration. Our best hope for the future lies in scientific literacy, critical thinking, and bold investment in the unknown. The spirit of discovery is our greatest inheritance, and our path forward.